Hey everyone, and welcome to Nerdwork Nexus, the show where we take your questions and dive deep into the research to give you the ultimate knowledge boost.
I'm excited to be here.
We're tackling a question that could make or break your academic journey.
Oh, this is a big one.
What's the real difference between majoring in physics and engineering physics?
Two fields that sound so similar,
They do.
but trust me, understanding the nuances could be the key to choosing the right path.
So let's get right to it. What exactly is the difference between physics and engineering physics?
Well, they both involve physics, right?
Right.
But it's not just a fancy wording situation.
Okay.
Both fields are deeply rooted in the principles of physics, but they kind of diverge in their approaches and their ultimate goals.
Okay.
Think of physics as the quest to unravel the fundamental laws of the universe.
Oh, that's a good one.
It's about understanding the why behind everything.
So physicists are like the detectives of the universe.
Yeah. Searching for clues to understand how it all works at its core.
I like that analogy.
They're driven by curiosity, a desire to uncover the hidden mechanisms that kind of govern the very fabric of reality.
Okay, so that's physics.
Right.
What about engineering physics?
Engineering physics, on the other hand,
Okay.
it takes those fundamental principles that the physicists have discovered and seeks to apply them
Ah,
to solve real-world problems.
Got it.
And to create new technology.
so they're taking those discoveries and turning them into something tangible and useful.
Exactly. They use their knowledge of physics to design, build, and innovate.
Okay, that makes sense.
What?
But is there any overlap between the two fields?
Absolutely. In fact, you'll find that the initial coursework for both majors often overlaps, especially in the first year.
Right.
Both physics and engineering physics students typically start with foundational courses in mechanics, electromagnetism, and calculus.
So they both get that shared foundation.
They do. This ensures that regardless of which path you choose, you'll have a strong grasp of the core principles.
So when do the paths start to diverge?
Well, as you progress through your undergraduate studies, you'll notice the coursework starts to branch out.
Okay.
Physics majors will delve deeper into theoretical concepts, exploring areas like quantum mechanics,
Oh, wow.
relativity, and particle physics. They'll also engage in advanced mathematical modeling and potentially even specialize in a particular subfield.
So physics majors really get to go deep into the theoretical rabbit hole.
Exactly.
What about engineering physics majors?
Their focus shifts towards applying those theoretical principles to practical situations.
Okay.
They'll start taking courses in areas like electrical circuits, thermodynamics, and material science.
Mhm.
And here's where a key distinction comes in many engineering physics programs,
Yeah.
especially those accredited by ABET, include a mandatory design component.
Hold on. ABET accreditation, what's
What?
that?
ABET stands for the Accreditation Board for Engineering and Technology.
Okay.
It's a non-governmental organization that accredits college and university programs in applied and natural science, computing, engineering, and engineering technology.
So it's kind of like a stamp of approval.
Exactly. It means that an engineering physics program meets certain quality standards and includes specific coursework designed to prepare graduates for engineering roles.
So if a program's ABET accredited, it tells employers that grads have the skills they need.
Right, to hit the ground running in an engineering setting.
That makes a lot of sense.
I
Now, what about career paths? Do both physics and engineering physics majors lead to the same jobs?
Well, there's definitely some overlap.
Okay.
Both physics and engineering physics grads are sought after for their analytical thinking, problem-solving abilities, and strong mathematical foundation.
Makes sense.
But that ABET accreditation that we mentioned might give engineering physics graduates a slight edge when applying for specific engineering positions.
Oh, interesting.
Yeah, it really boils down to your individual interests and career goals.
Our listener was curious about theoretical physics as a career path.
Okay.
And one of the sources mentioned that theoretical physics is a long road that requires extreme dedication.
And that's true. A career in theoretical physics, especially if you're aiming for a research-focused position at a university or a research institution, often involves completing a PhD,
Okay.
followed by several years of postdoctoral research before even landing a permanent position.
Oh, wow.
It's a demanding path that requires passion, perseverance, and a deep love of theoretical exploration.
So it's not for the faint of heart.
No, it's not.
What about those interested in experimental physics or some of the newer fields like nanotechnology or quantum computing? Are both majors equally well suited for those paths?
Absolutely. In fact, I think this is where things get really exciting.
Ooh, here's where it gets interesting.
Yeah, so one of the sources mentioned the rapid advancements in 21st century technology
Okay.
and how both physics and engineering physics majors are poised to play significant roles in shaping shaping the future.
So tell me more. What does the future hold for these fields?
The lines between these disciplines are becoming increasingly blurred, especially with the rise of fields like renewable energy, nanotechnology, quantum computing, and even areas we haven't even imagined yet.
Okay, I'm officially hooked. This is starting to sound like something straight out of a sci-fi novel. But before we get too caught up in the future, let's recap what we've learned so far.
Sounds good.
So, we started by defining physics as the quest to understand the fundamental laws of the universe that deep dive into the why behind everything.
Right.
Then we talked about engineering physics, which takes those principles and applies them to solve real-world problems and create new technologies.
Yeah.
And we also explored the different paths each major takes in terms of coursework, with physics focusing on the theoretical and engineering physics emphasizing the practical.
And we can't forget about ABET accreditation, which can give engineering physics grads an advantage in certain job markets.
Right. But regardless of which path you choose, both physics and engineering physics majors develop valuable skills that are in high demand in today's world: analytical thinking, problem solving, and a strong foundation in math and science.
Exactly.
Okay, but what about the future? Where do you see these fields heading in the next 10, 20, even 50 years?
Well, that's a question that could take us down a fascinating rabbit hole of possibilities.
Let's go down the rabbit hole.
So, picking up where we left off, let's look at some trends shaping the future of physics and engineering physics. One that immediately comes to mind is the rising role of computation and data analysis.
Okay.
As we conduct larger and more complex experiments, whether we're smashing particles in accelerators
Right.
or gathering data from space telescopes, we're generating an overwhelming amount of data.
Yeah, that makes sense.
And the ability to process and interpret that information is becoming absolutely crucial.
So it's not just about understanding the theories anymore. It's about being able to sift through all that data to find meaningful patterns.
Exactly. Physicists and engineering physicists of the future are going to need a strong grasp of coding algorithms and statistical analysis.
So those skills are no longer optional.
They're essential for anyone working at the forefront of scientific discovery.
That's wild. Okay, so that's one trend. What else?
Another really exciting trend is the rise of quantum technologies.
Quantum technologies. That sounds pretty futuristic.
It does, right? But it's rapidly becoming a reality.
Wow.
Quantum computers, for example,
Yeah.
have the potential to revolutionize fields like medicine materials, science, and artificial intelligence.
That's incredible.
And physicists and engineering physicists are at the forefront of developing and applying these groundbreaking technologies.
So if a student is interested in quantum technologies, they could major in either physics or engineering physics.
Absolutely. Both majors provide a strong foundation in the principles of quantum mechanics, which is essential for understanding and working with these technologies.
Okay.
The choice might come down to whether you're more interested in the theoretical underpinnings of quantum phenomena
Right.
or the practical applications of those principles.
So it really depends what you want to do with your knowledge of quantum mechanics.
Exactly.
This is all incredibly fascinating, but I can imagine it can also be a bit overwhelming for someone who is just starting out.
Oh, for sure.
What advice would you give to students who are trying to decide between these two majors?
I would say, first and foremost, follow your passion.
Always good advice.
What truly excites you about science and technology?
Yeah, what gets you out of bed in the morning?
Exactly. If you're captivated by the mysteries of the universe and want to delve into the fundamental laws of nature, then physics might be the perfect fit.
Okay.
But if you're drawn to solving real-world problems and creating innovative solutions, then engineering physics could be the path for you.
It sounds like a love of learning and a willingness to embrace challenges are pretty essential for both paths.
Absolutely. These fields are constantly evolving, so a curious mind and a desire to kind of push the boundaries are essential.
I like that.
I would also encourage students to reach out to professors, researchers, or professionals working in fields that interest them.
Get out there and network.
Yeah. Attend seminars, join clubs, and seek out opportunities to gain hands-on experience, whether it's through research internships or design projects.
Those real-world experiences can be so valuable.
Absolutely. And remember, choosing a major is not a life sentence.
That's a good point.
Your undergraduate years are a time for exploration. You can always adjust your course along the way, pursue a double major, or even transition to a related field if your interests evolve.
So the key is to stay open to possibilities.
Exactly. The important thing is to stay curious, keep learning, and embrace the journey. Speaking of journeys, we've reached the end of our dive into the future of physics and engineering physics.
It's been a pleasure exploring these fascinating fields with you and with our listener.
Likewise.